All right, so today we're solving equations using addition and subtraction. All right, so what you're going to see in today's lesson is that some of your equations you probably can solve using mental math, right? Okay, so let's look at the first equation. It says equations have one solution to the variable that makes it true, meaning there's one value that I could plug in for x to make that equation true. What value do you think that is? It's 5, okay? 5 plus 5 equals 10. Can I just decide one day that 4 plus 5 equals 10 and say that's true? No. 4 plus 5 does not equal 10. There's only one value that would make that equation true. Okay? So, how do I solve equations? You say, well, I don't need to show any work on that equation because I can do it mental math. And you are correct. All right, and normally I wouldn't tell you to look ahead in your notes, but just real quick, okay, so you kind of feel the last page in your notes. I want you to feel the last 2 pages and then fold it back, okay? And you should see the page in your notes that says solving equations with variables on both sides. So you're going to go 2 pages in from the back. Do you guys see that lesson? I want you to look at those equations. Do you think that you could look at those equations and know automatically what x equals? Can I just look at that first one and say, oh yeah, x is going to equal whatever? No, I can't. Okay? So the reason we start with basic equations in our first lesson is to show us the process. You can go ahead and go back to the first lesson. Is to show us the process of solving an equation. So when you get to the really difficult lesson in lesson 3, you know the process and you can still solve them, okay? I've never had students really struggle with that part of it if they learn the fundamentals and the basics. So what are the fundamentals? Here's my key. You use opposite operations to solve equations. And we'll talk more about that in just a second. Here's your ultimate goal, whether it's the most difficult equation or the most basic equation. You solve equations the same way. You want to get the variable by itself. Okay? Get that variable by itself. All right, so example 1. I focus on the side with my variable. Does everybody see that it's x minus 5 on one side of the equation? My goal is to get x by itself. So I look and see what operation is connected to x. What is it? Subtraction or minus, okay? So what's the opposite of subtraction? Addition. So my property of equality, all right, there's another. All right, so let's try p minus 5 equals negative 2. All right, so Mikhail, what do you think would be the opposite operation here? Addition, because subtraction is connected to my variable. So what would I add to both sides? I would add 5 to both sides. All right, so again, I've got my inverses that cancel and add 5 to my other side. P equals, Haley, what's negative 2 plus 5? 3. So P equals 3. So let's say, okay, I think that these are my answers, but I just want to make sure. I want to double check and see if my answer is correct. All right, now this will always be an optional step for you, okay? But you can take that value and plug it back into the original equation. So when I plug it back in, is it true that 4 minus 5 equals negative 1? Is that true? Is 4 minus 5 negative 1? So I know that 4 is my answer. Same thing can happen on P. Is it true that 3 minus 5 is negative 2? Yes. So I know that 3 is my answer. You can do that pretty quick mental math, can't you? Okay, so that's just a quick, easy way that you could check your solutions. All right, so we treat fractions and decimals the same way. Okay, so I still look to see what operation is connected to my variable. Y'all tell me. What operation is connected to my variable? I'm pointing to it. Addition, right? Addition is connected to my variable. So what's the opposite of addition? Subtraction. I do want you to show that underneath, okay? We don't like vertical subtraction. However, because these are inverses, that's pretty easy, right? They cancel out. Now, on the other side, whenever we're working with fractions, I do want you to subtract on the other side horizontally. Why do you think I would want you to write the subtraction horizontally? Why do you think that would be helpful versus stacked on top of each other with a fraction? Why do you think? Mikhail, what do you think? Yeah, because what can you easily see? What is my number one rule before I can add or subtract a fraction? Common denominators. So don't you agree that it's easier to see when it's horizontal if there's a common denominator? Okay? So do I need to subtract my denominators? No. Okay? The negative belongs with the numerator. All right? So what is 1 minus 3? What's 1 minus 3? Y'all tell me. It's negative 2. Okay? So z equals negative 2 over 2. All right? Now, is that fully reduced? Can I reduce that? What can I reduce it to?
1.
Z equals negative 1. Okay? Negative 1. And that's my answer. All right? Now let's look at W. W plus 13.2 equals 10.4. What do you guys think? Zoe, what do you think you need to do? We're looking on the side with our variable to get that variable by itself. Mm-hmm. Yes, very good. Minus 13.2 on each side. 13.2. But wait a second. Can I just subtract these the way that they're stacked right now? No. Emily, do you have a question?
Oh, I was just going to say something.
Okay, good. You're already ahead of me. So do you think it would be a little bit better, because we agree the way it's stacked, you have to have your larger absolute value on top. So instead of writing negative 13.2 on bottom, what if I write it here? Okay? And then do my subtraction. All right? So now, 2 minus 4, I need to borrow to get 8. 2 minus 0 is 2. Now, don't forget your sign. Is it going to be positive 2.8 or negative 2.8? Negative 2.8. Does everybody understand why I wrote the negative 13.2 on top? Okay? Because when you're subtracting decimals, the larger absolute value has to go on top. Okay? So that way, I was able to do my subtraction. All right? So you guys, obviously, we know the common theme here, right? You're going to solve equations with integers. You're going to solve them with fractions. And you're going to solve them with decimals. They come as a package. Okay? So probably you've noticed a theme there. All right, how do we do on example 1? Do you okay on example 1? All right, so a big part of this lesson is learning how to write your own equation. All right, and I'll be honest, that's definitely the trickier part, isn't it? Okay, when we actually have to come up with our own equation. So in these 3 statements, we see something common. All right, and I want to draw your attention to this word, is. Is my key word for, does anybody have a guess at it? What is my key word for is? Y'all tell me. That's your equals. That's your equals. Is my equals. Okay? So wherever you see is, that's where your equal sign goes. I always tell my students, guys, start with the easy part, right? I think one thing that makes us overwhelmed with writing equations is we try to figure out all at once. Instead of starting with, okay, what's my step 1? What's my step 2? What's my step 3? Okay? So step 1, equal sign. You think you guys can handle that? Absolutely. Now, step 2 is to figure out my total or my final amount. Well, with the statement, it's going to be the value that comes after the word is. That's not too bad, right? Okay, so on the first one, what value would come after equals? Negative 10. Okay? Now, the front part is always going to be my challenge. The difference of 4 and a number, n, is negative 10. So when I see difference, what key word is that in operation, or is that? Subtraction. Okay? Now, but does that mean that I put the subtraction sign exactly where I see it and make it negative 4? No, it says the difference of 4 and a number. So that's where I insert my operation. Okay? So the difference of 4 and a number is negative 10. So oftentimes I'll see people say negative 4 plus n. Okay? Because they think and means plus. That is simply where you plug in your subtraction. Okay? Now let's talk about the second statement. If something is more than another value, it is being compared to or added to a value. Would you agree? Now let's talk about less than. If something is less than another value, you're taking it from that value. Would you agree? So if I said, I'm 5 years less than my sister, okay? I know we would normally say younger than, but if I'm 5 years less than her, okay, then that means, and she's, say, 35. How old am I? 30, right? Because I'm less than her age. I'm taking it from her age. So anytime you see more than or less than, you are actually adding that number to a variable. That's when it switches. That's the only time that you reverse the order. Because in order for 15 to be more than something, you have to be adding it to a number. Okay? You say, well, Ms. Kinder, it doesn't matter with addition, right? I can switch the order. And you're right, but you can't with subtraction. So that's why the order matters. Okay? Is 5. All right, so anytime you see more than, less than, or fewer than, you're going to reverse the order. All right? Okay, you try the third one on your own. The difference of a number p and 8 is negative 20.
Like, say the answer?
Yep, go ahead and say the answer.
P equals negative 12.
Okay, not the answer, like the equation. You actually didn't have to solve, but you got it correct.
Plus 8 and plus 8.
Okay, so, right, but did you write p minus 8 equals negative 20?
Oh.
Okay, so all I'm looking for is the equation, all right? But she is correct. You would add 8 to both sides, and it would be negative 12. All right, so she was just kind of a step ahead of us. All right, very good. Very good. Mikhail?
In addition, you could switch it around.
In addition, you could switch it around. Is that what you said? Yeah, community property, you could. You could. I'm not going to mark it wrong. However, with subtraction, the order is going to matter. Okay, so you got to get the order right on subtraction. And same thing goes with division. With multiplication, you can get away with switching things around too. All right, so writing our own equation. Okay, so it's still continuing on with the same theme of writing our own equation. All right, so let's read the example and then we'll work on building the equation. Skydiving company has a profit of $750 this week. This profit is $900 more than the profit last week. Which equation can be used to find P? Okay, so what did I just say that we always start with when we're writing our own equation? The equal sign, okay? So again, stop trying to figure out the most complicated parts of the equation and just start with the simple, the equal sign, okay? Now remember, this is important, guys. You're not necessarily looking for the biggest number. You're looking for the final amount. What is your final amount? The amount that's not going to be connected to a variable. It is 750, okay? That's the value. That's your profit this week, okay? Now, this profit is $900 more than the profit last week. So right now I want you to think, what operation would you do between 750 and 900 to figure out that it's $900 more. What operation would you do, Kylie?
Addition.
Not necessarily. If it's more, if it's more than 900, then you would have to subtract it. Okay? So let me just put it into the equation. If you have to subtract it, all right, then that means addition, P plus 900. Okay? P meaning your profit last week. Okay? P plus 900 equals 750. So now, when you subtract 900, now you don't have to do this. We're already to our answer. What was your profit last week? Did you make any money? No. Your profit last week was negative $150. Okay? So let's think about this. If your profit this week was $750, but that number was $900 more than the profit last week, that means you were in the negative last week. Okay? So you can go back and kind of reason through it. Now, I know this is the part that I always come to, and you're like, okay, you lost me. All right? We need more practice, more than any other concept. Okay? More than any other concept, we've got to practice our scenario problems. That's the only way you're going to get better. All right? Correct answer is B. It's just the equation written in reverse, but it's still the same exact equation. All right. Okay. So now we're actually going to skip this one, and not because it's not important. Well, maybe not skip it, but let me just explain it. Okay. If the equations are equivalent, I'm going to have the same value for m. Okay. So m plus 3 equals negative 5. Let's just talk through this. Okay. How would I get m by itself? Y'all tell me. How would I get m by itself? Subtract 3. Subtract 3 from both sides. All right, so Halen, what would I get when I do negative 5 minus 3? Okay, so you got to figure out same sign or different. Negative 5 minus 3. What do you think? Same sign. Add.
So maybe.
Yep, very good. Negative 8. All right, and then Hudson, what would I do to both sides on the other equation? Okay, so what would I do to get m by itself? Not subtract it, but yes, very good. So focus on the side with the variable, and you would add 4 to both sides. Okay, so m equals, oh, look at there, negative 8. Okay, so because you have the same value for m, these equations are equivalent. All right, so that's all. I mean, if there were different values for m, then you would say no. Okay, so your notes are missing the graph, which the graph is super important. Okay, so let me just look up here at the screen so you can see the graph. Now, a graph means nothing without what we call the legend. Do you see the legend? All right, it's you and your friend. Your friend is the blue and you are the green. Are you following me so far?
You're the blue and you're the green.
Yes. Okay. All right. So this ordered pair down here tells me, all right, so we see 1, 2, 3, and 4. This is how many games have been played, and here's my score. All right. So the question says, what is your score after the 4th level? Well, after level 4, you can see that the dot is like in between. So we're not going to guess. We're going to set up an equation so we can tell exactly how many points we have. After the 4th game, all right, so 4 is my x value. Negative 8 is the value for my friend, okay? That's the total or the final amount for my friend, okay? So negative 8, all right? Now, I don't know how many points I had, all right? So P for points. But I do know that I had 33 more points than my friend, okay? So before you think that it's addition, okay, if I need to add, because it's 33 more, that means that I must subtract in my equation. Okay, so the opposite goes in your equation. I know that's the part that is hard to understand. So that you can add the points to your friend's score. Okay, if I had 33 more points than my friend, I need to add 33 to my friend's score, right? So in the equation, I have to have subtraction. I know that kind of sounds weird. And again, it's just going to take practice. All right, let's be on. I'll be honest with you. It's taken me practice to learn how to explain that. Okay, so I understand that it's challenging. So your points, what's negative 8 plus 33? You have 25 points. On the graph, does that roughly make sense? Look at the values that it's between, right? It's halfway between 20 and 30. So you have 25 points, okay? And you could label it PTS, points. Last example, and guys, I think this must be on your homework somewhere. Yeah, you can set up an equation, right? But guys, it's a parallelogram. This is a terrible example because both sides have to be the same, right? So it's 3.8. Okay? So now I guess what they're saying is I could set this up. I can add all the sides together. 8.3 plus 8.3 plus 3.8 plus x, because I don't know it, equals my total perimeter, 24.2. Then when you add them all together and you subtract, guess what you're going to get? 3.8. Okay? So, all right, that's everything you need to know for today. Because it's chapel day, and I'm putting this on the recording in case anybody's parents don't believe me. And I will change it in Big Ideas. I'm making this homework due on Monday. Okay? So tomorrow's a half day. But here, listen, guys. You need to start this homework tonight. Do not submit it necessarily because we're going to work on it tomorrow in class. But you're also working on your timelines, which are also due on Monday. So don't take tonight as a free pass, right? Because then you're going to end up with more homework over the weekend. But I do want time to work on this together with you. So it is due when? Monday. But does that mean that you do nothing tonight? No. Okay, so that's everything you need to know for this lesson.